Continuing with 4.4, still graphing functions and their rules. We talked in the previous video about how sometimes when lines are graphed out, we have to think about the real life context and think about if they're going to be using a continuous line, a solid line, or if it just makes sense to use points. So this is a little tricky when we see it at first. So hopefully this example brings it to life a little bit more as far as when we need to use continuous or discrete. With discrete, this is composed of distinct isolated points. There's no in between. Good rule of thumb is that if you can have fractions, then stick with continuous. But if it's a kind of a one and done, you buy one thing, you buy another thing, you can't buy fractions of it, then you may want to keep it discrete. But of course, each context is different. So let's see what's up with this one. We have Megan, who's buying eggs at the supermarket for $1.75 per carton. I see a number here, so I'm going to highlight on this because chances are it's important. The cost is a function of the number of cartons bought. What is the graph of the function? Is the function continuous or discrete? So I already helped you out, and I'm saying that x is going to be equal to the number of cartons. Y is the total cost. So we don't have an equation here, so let's just think this out in a normal context. If Megan buys eggs at the supermarket, one carton is going to be $1.75. So we know that no matter what, if we buy one carton, it's going to be $1.75. So how about if we buy nothing? Do we have to pay anything if we buy no eggs? Yeah, there's nothing. So these are 2 points we can already map out. 0, 0, seen here. The next point we just made 1.75. So this is pretty close to 2, but we'll mark it up here. So this is 1, comma 1.75. With the next point, let's think this out. How much is this going to increase if we just buy an additional carton of eggs? We already have one. Well, this should just go up 1.75. If you need a calculator for this, this is pretty easy arithmetic. Just 1.75 plus 1.75, 3.5, seen here. So this is another point we can map out. When x is 2, the outcome's $3.5. It's right in between 3 and 4. And ideally, this is going to keep going and going. Keep adding 1.75, 1.75, 1.75. This keeps going and going. So the graph, this is pretty much what we're going to have seen here. But let's ask ourselves, is this function continuous or discrete? Continuous, again, means that it's going to be a line that's unbroken. Discrete is just going to be a mix of dots. So should we draw a line actually between all of these points, or just keep them as points that are distinct? We should just keep these as discrete, actually, because we can't buy a fraction of a carton. We're just going to keep adding 175 and 175 and 175. So let's take this a bit further. We've already done 2 versions. If we add on another, 1.75, that's getting us 5.25. Approximately here. We add another version of 1.75. That gets us 7. Another will get us 8.75. So we'll keep this discrete. We don't want to fill in the line. Don't jump the gun and do that. This is fine keeping it discrete because we can't buy fractions of a carton. That being said, we start to see some functions where they're nonlinear, and we saw this at the beginning, I think, of the previous section, what the idea means if it's nonlinear. So we saw the idea of parabolas that look like this. We saw cubic functions, we saw absolute functions, and now we're actually graphing them out. So we have x squared minus 1. We have some values here for x, so just plug in away. Keep in mind that since we're squaring x, we want to think out first, -2 times -2, what's that going to be? Keep in mind they're both negative. Should be saying really 4 minus 1, positive 4 at that. So this outcome's 3. Do the same thing for when x is -1, but this outcome's going to quickly say 0. If you're not convinced, -1 times -1 is going to be +1. 1 minus 1 gets you 0. Fill in the rest. I'll give you a moment to try these next two while I'm graphing these. So while I'm graphing these, try these next two, where x is 1 and x is 2. What are these outcomes going to be? Should be saying that this outcome is 1 because we have 1 squared and we're deducting 1. Or sorry, this should be 0 actually. So 1 squared minus 1 equals y, but 1 squared is 1, so 1 minus 1 actually gets you 0. So that's that. And then you should also be saying 2, 3. Done deal. And we'll graph this out because we want to highlight on all the values in between. We'll use arrows to show that this keeps going. We soon see with graphing absolute value, as a quick refresher, absolute value shows distance. So as an example, the absolute value of 2 is going to be +2, the same way the absolute value of -2 is going to be 2. So we've seen absolute value before now with graphing. Absolute value, start with first when x is -2. If we take the absolute value of -2 and then deduct 4, this is really taking 2 minus 4. So your outcome here is -2. So we have -2, -2. When x is -1, absolute value of -1 minus 4, so really just 1 minus 4, so this is -3. Absolute value of 0 minus 4, it's just going to be 0 minus 4, so -4. And finally, when x is 1, absolute value of 1 minus 4, what do you think this outcome is going to be? Should be saying -3. You may want to take this time now, try when x is 2. Some of these problems can be tedious, just plugging in numbers and plugging in numbers. We'll soon see tips and tricks and way to do this without having to plug in numbers. You should be saying that this outcome here is 2. Drawing an arrow, keeping in mind this will look like a V. We'll have this extended, looks like a V, looks good to me. All of the arithmetic seems all right. If you have any questions on this, please email me. Let me know if I can help.